Hello everyone. Today we are going to talk about recursion tree method, one of the methods for solving recursive equations. We have already discussed substitution iterative methods in one of my previous videos. So in that video we solved it with an example. We will take the same example, same equation and solve it with the recursion tree method so that it can be further verified. Okay, so what is recursion tree method? In this method we every node represents a cost of a single subproblem and it is being solved in a recursive manner, right? And where you sum up all the nodes in on a same level to get the cost. Okay, so it forms in a sort of a tree, hence the name recursion tree method, right? So we look at this equation. This is the same equation we use to solve the substitution iterative method. We'll take the same equation and solve it with the recursion tree method. Okay, so when we take for the first step, we have what? We have I is equal to 0, that is the first step. The number of nodes would be 1, that is n square. There is no iteration, there is no recursion happening. Okay, and of course the sum is also 1. Now if we replace this n with n by 2, that is the first recursion occurs, and we have what? Two nodes. Recursion tree method, we have two nodes, both of them would be what? We replaced n with n by 2 and we get n by 2 whole square, right? So we sum both of these in the same level, we sum them up, we can get what? 2n upon 2 square or n square upon 2, whatever you want to call it. Now we replace this n upon 2 with what? With n upon 4, right? Because we replace it with n upon 4, that is next iteration, next recursion. So for the next recursion we replace this n with n upon 4. We get 4 nodes, that is each node has got further 2 sub nodes, and we get this tree form n upon 4 square, n upon 4 whole square, n upon 4 whole square, and so on, 4 times that. So we can just sum up the row as 4 times into n upon 4 square or n square upon 4, right? Okay, so next is what? Next we have n upon 8. So when you that is we go further down on the levels and we have 8 number of nodes. We sum them up, as you can see over here. We have n upon 8 whole squares, right? And we just sum them up, sum the row, and we get 8 into n upon 8 whole square or n square upon 8. And similarly we can keep on going that and expanding our tree longer and longer, right? So let's try to solve this the equation, find an equation, solve it with the values that we have already found. In the previous solution of substitution iterative method, in the previous video we have already seen that this equation basically constitutes what? This equation constitutes your geometric series. I've also given a reference so that you can see where it came from. Okay, and this geometric series can be represented by 1 minus 1 upon 2. If we just take common n square and we get 1 upon 2, 1 upon 4, 1 upon 8, and so on. So you replace it with 1 minus 1 upon 2. This solution becomes 2. So we get what? T of n is equal to 2n square, which gives us the conclusion that big O of n is equal to n square, and it is the same for the substitution iterative method that we solved in one of our previous videos, as well as this recursion tree method. It is the same, hence proving both our solutions. I hope you like the video. Kindly subscribe my channel. Thank you very much.